Alright, Math 3, Practice 2B.1.4, Dividing Rational Expressions. It says for problems 1 through 4, simplify each rational expression. Whenever possible, reduce the expression to its lowest terms. State any restrictions. Okay, so when we're dealing with fractions and division, we should remember that we can't divide fractions. We should also remember that if I divide by 2, timesing by 1/2 is the same thing. So the reciprocal of the opposite operation does the same thing. So instead of dividing by c over d, we would times by d over c and get the same result. So that's what we're doing. So basically we always take this last one, okay, and you may say, well, I can cancel right now. You can't. Okay, first you have to switch it. So I get 2x over 7 times x over 1. Then you can try to eliminate. Can't here, so we get 2x squared over 7. No x on the bottom, no restrictions. Okay, number 2, same idea. 3 over 5x times x over 5. The x's cancel. We get 3 over 25. Okay, number 3, 8x plus 3 over 5, can't reduce that one, times 9 over x, 9 times 8, 72x, 9 times 3 plus 27, over 5 times x, 5x. X cannot equal 0. That's the only restriction, because that's the only number that would make it 0. Okay, number 4. So we get 2x minus 4 over x plus 1 times x plus 2 over x. Can't simplify that one at all, so we use the Box-Berry model for the top. 2x negative 4, x positive 2, 2x squared, negative 4x, 4x, and negative 8. Those two cancel, and we're left with 2x squared minus 8 on top. Bottom, x times x is x squared, x times 1 is x. Remember, you may think that you can take this and eliminate it, but because of the plus and minus, we can't. So restrictions, x cannot equal 0, and then 1 squared plus 1, so negative 1 squared plus negative 1, that would be 0, or negative 1. I believe those are the only two restrictions we would have. Okay. Number 5, it says use your knowledge of rational expressions to complete problems 5 through 10. So this one's going to get switched. Okay. Let's start simplifying. 15, 5, and 3 make a negative 2, negative 5. So we get x minus 5 times x plus 3 over, and we're going to go the whole way, pull out a 2 and an x, so times x would be left over minus 4, times this one we don't have to flip, so we can pull out a 2, and we're left with, actually let's pull out a negative 2, so we'd be left with x squared minus 16, which x squared minus 16, 16 is 4 squared, that's a difference of squares, so that's x plus 4 times x minus 4. So we'll want to simplify that one further. Remember, if you ever see x squared minus a number that can be squared, that rule applies. That should have been 4, not 5. X minus 4. The bottom, factors of 40 that would add up to 13, 8 and 5, if they're both negative. So x minus 5, x minus 8. Then these ones would flip, so x plus 4 would go on the bottom, and then we could pull out an x, and we'd be left with 8 minus x squared. So let's actually pull out a negative x. So times a negative x, and we'd have a positive x minus 8. Okay, So x minus 5 cancels, x minus 4 cancels, x minus 8 cancels, x plus 4 cancels, 2 cancels, x cancels, negative times a negative becomes a positive, all that's left over is x plus 3. And that's how it all gets eliminated. Alright, number 6 says use synthetic division to rewrite the rational expression. Alright, remember synthetic division? That's our divisor. It's not negative 5 because it's x minus the number, so positive 5. Take the coefficients, 2, negative 7, negative 15. Bring the first one down, multiply, take it up here, 10, add 17. 5 times 17 is a big number, 585. Add them together, and that's like 85 minus 15, so we'd get 70. So it'd be 2x, our depressed polynomial, 2x plus 17 plus 70 over x minus 5 is what we do. Second one, same idea. It's plus 1, so we go negative 1, 1, negative 8, negative 1. Bring down the 1 times, negative 1, add, negative 9, positive 9, add, positive 8. Now remember, if the remainder is 0, we know it's a factor, and we like that. So then I go x minus 9 plus 8 over x plus 1. Okay, number 8. One way to find average velocity is to take the quotient, and so that's what we're doing. Okay, of a car that covers a distance of 2x plus 4 in a total time in hours described by the expression. So we've got 2x plus 4 over 1 divided by 3x minus 6 over x plus minus 2. But we know that we actually have to flip and multiply. So x minus 2 would go up here, 3x minus 6, which I should notice I can pull a 3 out of those. So I'd be left with x minus 2. So those would actually cancel. So I'd end up with 2x plus 4 over 3. And that's my answer. Okay. Number 9. Density is the ratio of an object's mass to its volume. What simplified rational expression represents the density of an alloy ingot whose mass in grams is described by this expression with a volume in cubic meters by this. So it looks like we'd go 6x squared plus x minus 15, which let's start reducing that. So remember, if I go 6 times 15, negative 15, that's 90, isn't it? Yeah. So we'd have negative 90, factors of negative 90 that would add up to positive 1. How about 10 and 9, if 9 were negative? So we do the area model. I've got negative 15. I've got 6x squared. And we've got 10x and negative 9x. Well, negative 9 would be like negative 3 times positive 3. 15 could have a negative 3 times positive 5. 10 could have a 5 times 2. 6 could have a 3 times 2. So a positive 3x, okay, a positive 5, a positive 2x, and a negative 3. So I get 2x minus 3 times 3x plus 5 over x plus 4. Now, if I flip this, then I multiply it. So this would be times 5x. Then that bottom, can we simplify the bottom? Well, 2 times 12 would be 24. Factors of 24 that equal negative 11. 3 and 8, negative 3 and negative 8. So once again, so I've got 12, 2x squared, that should be an 8, negative 3x, and negative 8x. So 8 would be like 2 times 4, 2 times negative 4. 12 would be like negative 4 times negative 3. So I take out an x, take out a 2x, take out a negative 3, and take out a negative 4. So on the bottom I'd end up with x minus 4 times 2x minus 3. So those would simplify, and I think that's all we can do. So 5 times 3x would be 15x squared. 5 times 5 would be plus 25x over, if we multiply these out, we remember that difference of squares, this, we're just doing it backwards, so we'd actually end up with x squared minus 4 squared, which is x squared minus 16. Okay? Once again, you think you can eliminate those, but because of the plus and the minus, they're a package deal, we cannot. So there's our answer. Okay, does it have a restriction? Yeah, if x is 4. X cannot equal 4 or negative 4. Alright, last one. Number 10. The area of a right triangle in square meters is represented by the rational expression this, okay, where x is greater than 2. If the length of one leg in meters is described by the rational expression, what represents the other leg? So area of a right triangle equals 1/2 times base times height, right? So we want to find the other leg. So we know the area, so we're going to, we would basically times everything by 2, and then we divide. That would eliminate that. We divide by the base or the height. So we've got 2 times this expression, and then we're going to divide by this one. So we're going to basically end up timesing by its reciprocal. So factors of 5, that could be negative 3. 5 and 1. So we might not be able to simplify this one, guys. We have x minus 2 on the bottom. This will flip, so we'll have x minus 1 on the top. And on the bottom, x squared minus 5. So yeah, x squared minus 3x plus 5. Don't see a way we can simplify any of those. So we're just going to have to multiply things out. So using that area model is going to be our best bet. So the first one, we're going to have a 3 by 2. So x and negative 1, x squared, negative 3x, positive 5, x cubed, negative 3x squared, 5x, negative x squared, positive 3x, negative 5. Okay, and all that's basically being times by 2. So we would have 2x cubed, that would make negative 4, negative 8x squared, that would be 8, so 16x and negative 10. Over, we do the area model for that last one, so x and negative 2, x squared and negative 5. So we get x cubed, negative 2x squared, negative 5x, and positive 10. So x cubed minus 2x squared minus 5x plus 10. Could this possibly simplify into something that we could do more with? Possibly, but because we couldn't do the smaller pieces, I doubt it's going to happen. I don't think it changes it that much. So there's our answer. Now, any restrictions? Take this. The easiest thing to do would be to graph it and to find its x-intercepts. Let's do that. So we graph that, and we find we have some zeros here. So we zoom in on this spot, and we see that one restriction would be x could not equal negative 2.236. It could also not equal positive 2 and positive 2.236. So it's got 3 zeros for the restrictions there. Okay? And there we go.